Chapter 2.2, Basic Differentiation Rules and Rates of Change, Day 2. Today, we're going to look at the rules we talked about yesterday and just apply them in a few more examples. So in review, we learned 4 rules yesterday. The constant rule, the power rule, the constant multiple rule, and the sum and difference rule. All right? So our first example applies 3 of the rules. We got actually all 4. The first one, y equals 3x to the 8th plus 2x plus 1. It's the sum and difference rules because we got 3 things added together. So we'll take the derivative of each of those 3 things. 3x to the 8th is the constant multiple rule because we got 3 multiplied by x to the 8th. And x to the 8th is the power rule. So we'll start this off, dy dx equals, we'll take 3 times 8, which gives us 24x, and then 8 needs to power down, x to the 7th. The derivative of 2x is 2, and the derivative of 1 is 0 because it's a constant. All right. The next example, y equals pi to the 3rd. This one tricks a lot of people. Pi, remember, is constant. It never changes. It's always 3.14. So what we have here is y equals a constant. And what's the derivative of a constant? That's right. The derivative of a constant is 0. Our next function. A little bit has been done to this function. Notice there's parentheses around it, and it's multiplied by 1/2. Well, a couple things we could do. One, probably the easiest thing would be to distribute the 1/2. All right, you could also use the constant multiple rule. I'm going to distribute. It makes other problems later easier if we just stick with the distribution. 1/2 x to the 4th plus 7/2. Now we'll apply our derivatives. We'll take the derivative of each piece. Take 4 times 1/2, we got 2x, and then 4 powers down to 3. And then 7/2 is constant. So the derivative of 7/2 is 0. Okay, this next one, this one's a new function. This one's a fraction. We got 3 things on top of our fraction and 1 thing on the bottom. Now what we do here, we have an addition subtraction problem at the top. We can rewrite this as 3 separate fractions, all with the common denominator. We can refer to it kind of as a 3 on 1. All right, we got 3 separate terms all on top of 1. So we can split it. So h of x, we can rewrite it as 2x squared over x minus 3x over x plus 1 over x. All right, and then what we want to do here is kind of simplify. We don't like to have fractions for derivatives. All right, so the 2x squared over x, that simplifies to 2x. The 3x over x simplifies to 3. And then the 1 over x, we like to rewrite that as x to the negative 1. It's easier to deal with if we have a power than if we have a fraction. So all fractionals, like we got right here, we're going to rewrite them in power form with exponents. And now it's simply a matter of applying our exponent rules. X prime of x, well, the derivative of 2x is 2. 3 is a constant. Then we'll take our negative 1, we'll multiply it out front, minus x, and then negative 1 powers to negative 2. So whenever we have a fraction with 1 term on the bottom, we're going to then split it into 3 fractions or 4 fractions, however many terms we get up on top, all over the denominator. Okay? Right. This problem, y equals pi over 3x squared. What we want to do here is we want to rewrite it so there's no fraction. All right. First thing I'm going to have you do is we're going to take this 2 and we're going to apply it to each term inside the parentheses. All right, so we can rewrite this as y equals pi over 9, because 3 squared is 9. 3 squared is 9, and then x squared. All right, but we don't want x in the bottom, so I'm going to bring x up to the top. And I can rewrite this as pi over 9 x to the negative 2. Now I have it in a nice, easy form where I can take my derivative, dy dx. The 2 or the negative 2 will multiply out front. It will be negative 2 pi over 9 x to the, and then negative 2, when you go down from negative 2, you get negative 3. All right, the next one, okay, this one initially does look quite tricky. However, if you just get rid of the radicals, you can get rid of these radicals and get rid of the fraction. All right, so what we want to do here, the square root is what power? Well, the square root is the 1/2 power. So what we got, really, instead of saying 5 times the square root of x to the 3rd, that's the same thing as saying 5x to the 3/2. Plus, we got our 3, and then the cube root of x is x to the 1/3. However, we want it to be up top instead of in the denominator. We want it in the numerator. And to do that, we just go negative 1/3. And from there, now we can find our derivative. The 3/2 will be multiplied by 5, so that becomes 15/2. And then 3/2, if you minus 1, you're really minusing 2/2. 3/2 minus 2/2 is 1/2. And then we'll take our negative 1/3 times 3. We get negative 1x. And then negative 1/3, subtract 1. You're really subtracting 3/3. You get negative 4/3. Basically, you're subtracting the numerator from the denominator. In the first one, you took 3 minus 2, and got 1. Here you take negative 1 minus 3, and get negative 4. All right, the next problem. All right, same problem. Actually, no, this is actually an easy problem. Notice the x is not underneath the radical. Okay, so right here, the x is not underneath the radical. There's no variable in this part. That means it's constant. All right, so as we work through this, power 1 times the square root of 2. Power down, x to the 0 is 1. So we can leave it as square root of 2. And then 1 over the square root of 2 is a constant, so that's derivative 0. So this one, the derivative is square root of 2. All right, this is the 2 on 1. We got a fraction with 2 things up top, 1 thing on the bottom. So we're going to split it. We got 1/5 x squared plus 1/5. And then take the derivative of each piece. So our derivative, dy dx, 2 times 1/5 is 2/5, x to the 1st, and then 1/5 is a constant. So we'll need the derivative of 1/5. This one, y equals 3x squared plus 6 times 2x minus 1/4. This one we need to simplify first, and we simplify by foiling. All right, we'll FOIL this out. 3x squared times 2x, that's 6, x to the 3rd. 3x squared times 1/4 minus 3/4 x squared. Inside, 6 times 2x is 12x. And then our last terms, 6 times negative 1/4 is minus 6/4 or 3/2. We'll simplify later. Now that we've FOILed it, we can take our derivative, dy dx. Power rule, 3 times 6 is 18x squared. 2 times 3/4 is 3/2. X to the first, 2 powers down to 1. Derivative of 12x is 12. And the derivative of 6/4, well, that's constant, so that's 0. So in this case, dy dx equals 18x squared minus 3/2 x plus 12. Okay, same problem, different appearance. It's being squared, so we need to FOIL it out. If you remember the shortcut for squaring a perfect square, it's x. You square the first one, multiply them and double it, so 4x to the 6th plus 4x squared. And from here, we just do our derivative, dy dx equals 10x to the 9th plus 24x to the 5th plus 8x. And then our last problem, it's a 2-on-1, so we'll split it. That and that. 3x over x, I can reduce to 3. 2 over x, we can rewrite that as 2x to the negative 1. And then dy dx. 3 is a constant, so the derivative of 3 is 0. So then we got negative 2 is negative 1 times 2 is negative 2. X, and then power down, negative 2x and negative 2. If you want, you can rewrite that as negative 2 over x squared, but that is totally unnecessary. So in review, the constant rule, derivative of a constant is 0. The power rule, x to the n, the derivative is nx to the n minus 1. The constant multiple rule and the sum and product rule. I'll use these to help us find derivatives a lot quicker.